Richard Sutton, father of RL, thinks LLMs are a dead end. What's this? Hello, I'm Chris Thanis. I'm a KMP developer, and I like to talk about the AI stuff. There's good parts of it, there's bad parts of it, and I only previewed the first few minutes of this thing. It looks really good, but I think finally we get somebody with some gray hair, like talking some sense about what these things are for, and can reduce the hype level a little bit. Maybe get some realism. What's going on with these AI models? Which really aren't models. It's just word guessing things, systems, whatever you want to call them. And let's go ahead and see what this guy is saying.
An action, a good action to take.
Oh wait,
You recognize that.
I don't know why it does that. There we go.
Why are you trying to distinguish humans? Humans are animals. What we have in common is more interesting. What distinguishes us, we should be paying less attention to.
I mean, we're trying to replicate intelligence, right? No animal can go to the moon or make semiconductors. So we want to understand what makes humans special.
So I like the way you consider that obvious, because I consider the opposite obvious. If we understood a squirrel, we'd be almost all the way there. I am personally just kind of content to be out of sync with my field for a long period of time, perhaps decades, because occasionally I have improved right in the past. I don't think learning is really about training. It's about an active process. The child tries things and sees what happens. I think we should be proud that we are giving rise to this great transition in the universe.
Today, I'm chatting with Richard Sutton, who is one of the founding fathers of reinforcement learning and inventor of many of the main techniques used there, like TD learning and policy gradient methods. And for that, he received this year's Turing Award, which, if you don't know, is basically the Nobel Prize for computer science. Richard, congratulations.
Hey, no joke.
And thanks for coming on the podcast.
It's my pleasure.
Okay, so first question. My audience and I are familiar with the LLM way of thinking about AI. Conceptually, what are we missing in terms of thinking about AI from the RL perspective?
Well, yes, I think it's really quite a different point of view, and it can easily get separated and lose the ability to talk to each other.
Mm-hmm.
And yeah, large language models have become such a big thing, generative AI in general, a big thing. And our field is subject to bandwagons and fashions.
Absolutely, so yeah. I just want to stop there for a second. Oh yeah, we've had a series of these things, and when we're in the middle of it, it seems like that we're in the middle of the most amazing thing ever until the hype wave ends. To the hype wave, that first, the valley of the doubt comes in. When people do like, okay, this isn't gonna end the universe. It's just another step ahead. But when we're in the middle of it, it feels like, oh my God, this is the most ultimate thing ever. And the AI stuff, the stuff that we've seen, the LLM stuff, is a preview of what coming attractions. But is this gonna make it? Probably not. If it was gonna do it, it'd already be doing it. That's the thing. That's the way we know. It would have been doing it within minutes. In fact, it would have been doing it so well, they wouldn't let anybody have access to it. So let's keep going.
Lose track of the basic things. Because I consider reinforcement learning to be basic AI. And sure. What is intelligence? The problem is to understand your world. And reinforcement learning is about understanding your world. Right. Whereas large language models are about mimicking people. Doing what people say you should do. They're not about figuring out what to do.
Yeah, well, not even mimicking people. Mimicking what people have written down. And not even what people have written down, just what's written down. Let's be real clear about that.
Huh. I guess you would think that to emulate the trillions of tokens in the corpus of internet text, you would have to build a world model. In fact, these models do seem to have very robust world models, and they're the best world models we've made to date in AI, right? So what do you think that's missing?
I would disagree with most of the things you just said.
Yeah, me too. Same here. I feel like I was the only one, but he does the same thing. He thinks he's thinking the same thing I'm thinking after using these for a few years. And people still saying, no, we're about to turn the corner. The next model's going to be amazing. Each model is just like, it's going to be 2% better. 1%, just a little bit worse. But no, we fudged the numbers. You won't find out till later, until people look into it. But we're going to do a big announcement. Everyone just buys the announcement. That's enough to pump our stock price. And that's all we care about.
Just to mimic what people say is not really to build a model of the world at all, I don't think. You're mimicking things that have a model of the world.
Well, not what people say. Not what people say. What people have written. Not what people say. I mean, I guess the YouTube stuff, but even that's just what people have expressed. That's like a tippy little tip of the iceberg of the human experience. Like a tiny little part. Like there's this massive, huge amount of tacit knowledge that all humans share some of it, but not all of it. But that we just take for granted that the machines are completely confused about and have no idea what you're talking about. And don't have any conception of it. And because you can't write it down. Okay, let's keep going.
But I don't want to approach the question in an adversarial way. But I would question the idea that they have a world model. So a world model would enable you to predict what would happen.
Right.
They have the ability to predict what a person would say. They don't have the ability to predict what will happen.
Well, what is written down has said in the past, statistically speaking. Let's keep going.
What we want, I think, to quote Alan Turing, what we want is a machine that can learn from experience.
Right.
Where experience is the things that actually happen in your life. You do things.
Now that would be real artificial intelligence, right? And that's the part of the stuff they're not going to let us have any part of like anywhere near. Let's keep going.
You see what happens, and that's what you learn from.
Yeah.
The large language models learn from something else. They learn from here's a situation and here's what a person did.
Right.
And implicitly, the suggestion is
not a person. I got to keep stopping it because you keep saying this person thing. No, it's what someone wrote down. Maybe it's a group of people. Maybe it's another machine. Someone wrote it down somewhere. It's not actually what people think. It's what was written down. It's a really subtle distinction, but it's really, this is the thing about these chat model LM things, and they will never, not even close to being anywhere near what a human capable of having or creating or making, is because it's not really learning. It's just predicting what somebody that has written something down would do, or whatever would do, what they would say. The next word would be not even what they would say. It's just what the next word they possibly would say. Okay, let's be really clear about what's going on here, because we're not close to the AI thing that these stock pumping guys are into. These open AI, Sam Altman. We're going to change the world, but this is like, okay, well, this is just another tool on the stack of tools we have, like blockchain and all the, cloud computing. Oh, somebody else's computer. Like, we didn't have that from the very beginning. Let's keep going.
You should do what the person did.
Right. I guess maybe the crux, and I'm curious if you disagree with this, is some people will say, okay, so this imitation learning has given us a good prior, given these models a good prior, but reasonable ways to approach problems. And as we move towards the era of experience, as you call it, this prior is going to be the basis on which we teach these models from experience, because this gives them the opportunity to get answers right some of the time. And then on this, you can train them on experience. Did you agree with that perspective?
No, I agree that it's the large language model perspective.
Right.
That's how the LLMs think it's going to happen. It would have already happened by now. It would have happened within the first 6 months of them talking about this, if this was the valid path, but it's not. Then that's why we're here still going, hey, wait a second, you guys lied to us.
Yeah. Here's why.
So to be a prior for something, there has to be a real thing. I mean, a prior bit of knowledge should be the basis for actual knowledge. Right. What is actual knowledge? There's no definition of actual knowledge in that large language framework.
Correct.
What makes an action a good action to take?
Right.
You recognize the need for continual learning.
Right.
So if you need to learn continually means learning during the normal interaction with the world.
Yeah.
Right.
And so then there must be some way during the normal interaction to tell what's right.
Right.
Yep.
Okay, so
yeah, like these code things. Fucking compile the goddamn program. If you think your suggestion is so good, compile it or go run it. Go figure out what from this little thing you're adding here. Do the rest of it and make sure it's gonna be fit for purpose. No, you're just gonna let me go do that part and go, well, I'm sorry that we didn't give you the right thing. So you just make a bunch of work for me? Okay, so I really do need to go and know how everything that the code is the thing is being generated. That instead of me going looking up the documentation and doing my rough drafts, that's actually going to be the thing I needed to do. But is it going to go check it? No. Oh, God forbid. No, that's a human problem. That's where we make the money.
Is there any way for it to tell in a large language model setup to tell what's the right thing to say? You will say something and you will not get feedback about what the right thing to say is, because there's no definition of what the right thing to say is. There's no goal.
Right.
If there's no goal, then there's one thing to say. Another.
Yeah, people say it's hallucinating. No. The whole thing's hallucination. It just happens to be sometimes in alignment with reality. But let's be real, the whole thing's an hallucination. The fact that it works at all is kind of a magic. It's kind of magical. The fact that this stuff actually works at all. It's like a hint on how one part of our brain or how reality is put together, but it's not the answer. If it was, we wouldn't be hallucinating all the time. It would be very rare. Only when you gave it an artificial LSD, then it would hallucinate. Otherwise, it'd be like, no, I got this, because it's trained on 100,000 times more data than we could possibly consume in a lifetime. It should really know better by now, but it doesn't. So this isn't it. We're getting around it. This is one avenue to get something that looks kind of close, but it's not it.
Say there's no right thing to say.
Right.
So there's no ground truth. You can't have prior knowledge if you don't have ground truth. Because the prior knowledge is supposed to be a hint or an initial belief about what the truth is.
Right.
Yeah.
But there isn't any truth. There's no right thing to say. Right. Now, in reinforcement learning, there is a right thing to say or a right thing to do, because the right thing to do is the thing that gets you
Well,
reward.
it has to go test it. Or we have to go try out. Whatever the thing is suggested, go try it out. Tell me, fit it together for me. before. Don't make me go do it, but it hasn't done that. Why? It seems like such a logical first step. Like for CAMP, those libraries, when you have an update, and does this update going to conflict with everything else? Can you go figure that out for me? And this seems like a real straight up AI thing to do, an LLM thing that could go do this to chunk it out, man. No, you never heard of it? This is the most pain in the ass part of the damn thing. It takes hours. It's just to get you back to where you were before. The compatibility of cross compatibility with all these damn libraries. Oh no, version 1.8.6 doesn't work with version 1.6. You have to change your Kotlin version number and use this SDK with version 1.9. It's like, could you go please do that for me? Because at the end of the day, it's just gonna work or not. So could you please fix this? And it doesn't. We're not even. Why isn't that part of this? This should be part of it. Right? You're still going to need a human to direct this thing, but could you go take care of those dumb details we've been fucking grinding through the whole time with this Android thing? With I'm going to version just because you can upgrade the versions, yeah, but there's no standard. Anyway, there's no conflicting thing. There's no way to test easily what's compatible. You have to recompile. I'm okay. I can see God.
Right. So we have a definition of what's the right thing to do is, and so we can have prior knowledge or knowledge provided by people about what the right thing to do is, and then we can check it to see, because we have a definition of what the actual right thing to do is.
Right.
Yeah.
Now, an even simpler case is when you're trying to make a model of the world. When you predict what will happen, you predict and then you see what happens.
Right.
Okay, so there's ground truth. There's no ground truth in large language models.
Correct.
Because you don't have a prediction about what will happen next.
Right.
If you say something in your conversation,
because that takes a lot more computing power than just training these damn LLM models. It takes way more than that. Maybe that's why they're building all these data centers, preparing for that kind of shit. But man, I still think that they're so far off. They're so far off with any of this stuff, and their power consumption rates and stuff. Even with the nuclear power plants, they're gonna have to figure out something else, because they're not going to consume half the electricity on the planet just for run these computers. That's just not going to work.
The large language models have no prediction about what the person will say in response to that, or what the response will be.
I mean, I think they do. Like, you can literally ask them, what would you anticipate a user might say in response?
Yeah, but
and they have a prediction.
It doesn't do it like that.
Oh no, they will respond to that question, right?
Yeah.
But they have no prediction in the substantive sense,
right,
that they won't be surprised by what happens. And if something happens that isn't what you might say they predicted, they will not change. Because
it's like when you catch them out, like if you know some subject matter area and you catch them out with a lie, it'll like fill in back information that wasn't there in the beginning, even if you asked it to fill it in before you told it about something. It's like, what about this thing about that event, or this thing about this? Oh yeah, about that, yeah, of course. It's like such a bullshit thing. It's like the fact that they can even bullshit at all is like, okay, this is not it. This is something else. This is some weird. This is a mirage. Let's keep going.
An unexpected thing has happened, and to learn that, they'd have to make an adjustment.
So I think a capability like this does exist in context. So it's interesting to watch a model do chain of thought, and then suppose it's trying to solve a math problem. It'll say, okay, I'm going to approach this problem using this approach at first, and it'll write this out.
We're talking about like a real. The math problems the domain for math is like this big. It's like this big compared to the human, what we take for granted, just running around in the world. It's like this massive thing. Like, this is the experience of being a human being dealing with all this stuff. Is not just a little math problem, okay? It's a whole other category of thing, and they're saying, no, we're gonna get there with this. Like, we're not gonna get there with this.
And be like, oh wait, I just realized this is the wrong conceptual way to approach the problem. I'm gonna restart by this another approach, and that flexibility does exist in context, right? Do you have something else in mind, or do you just think that you need to extend this capability across longer horizons?
I'm just saying they don't have in any meaningful sense, they don't have a prediction of what will happen next. And they will not be surprised by what happens next. They'll not make any changes if something happens.
But isn't
based on what happens?
Isn't that literally what next token prediction is?
Right. So they've got some simulated stuff right now, but in this general case thing, no, we're far away, and it's clunky, and it doesn't really work. It doesn't actually. It's not doing what they say it does.
Prediction of what's next, and then updating on the surprise.
Next token is what they should say, what the action should be. It's not what the world will give them in response to what they do. Let's go back to their lack of goal.
Mm-hmm.
For me, having a goal is the essence of intelligence.
Right.
Something is intelligent if it can achieve goals. I like John McCarthy's definition that intelligence is the computational part of the ability to achieve.
And a big part of that is like, what is the actual goal? Defining what the goal is going to be. Is it even possible in this lifetime? How much energy will it require? Like all those limits putting up ahead. Sometimes the answer is like, no, I can't do that. You're just not going to do that with it. You'll not finish in a lifetime. Or it's going to take too many resources. It's not available right now. You have to do something else and come on. And then they can suggest about the other things it could be like, see, we're not close. And the thing is, even if we did have that stuff, they're not gonna let us have it. Come on, think. They would. What could you? What would? What could a person with evil intent, not nice intent, like most of the people probably watching this show and watching this channel, you have a good person, but think about the person with the evil intent. What they would do something with like that, something like a technology like that that actually existed. Horrible, mass death.
Goals. Yeah. So you have to have goals. You're not. You're just a behaving system. You're
Not that the machine does it, but people using the machine. It's not the machine, and the machine's never going to do anything. The machine's just this. It's like a leverage point. It's like, it's like instead of throwing a rock, you're using a gun. It's like it's a leveraging, but it's still something. It's the gun isn't shooting itself. Someone's shooting the gun. That's the danger. Is the human being getting a hold of something and letting I'm in charge now. I'm the captain. It's like
You're not anything special. You're not intelligent.
Right.
And you agree that large language models don't have goals.
I think they have a goal.
What's the goal?
Next token prediction.
That's not a goal. It doesn't change the world.
Right. But, I think we're thinking about different goals in different ways.
The tokens come at you, and if you predict them, you don't influence them.
Oh yeah, it's not a goal about the external world.
Yeah, it's not a goal. It's not a substantive goal. It's not. You can't look at a system and say, "Oh, it has a goal." If it's just sitting there predicting and being happy with itself that it's predicting accurately.
I guess maybe the bigger question I want to understand is why you don't think doing RL on top of LLMs is a productive direction, because we seem to be able to give these models a goal of solving difficult math problems, and they're in many ways at the very peaks of human level in the capacity to solve Math Olympiad type problems, right? They got gold at IMO. So it seems like the model which got gold at the International Math Olympiad does have the goal of getting math problems, right? So why can't
such a small, tiny little domain? It's like the chess thing. They had the same conversations around chess, same exact shit. It was just a computing issue. And do math problems for computers, because it's all based on logic. It's in this with its sweet spot. Honestly, I'd be surprised that it didn't do well with that stuff. But when we get outside the sweet spots, which is what people are saying we're about to just get, it's like, no, we're not about to get. No, we're far away. It's useful for certain things, but in this general intelligence thing, no, we want it to be. I wish it was Dwarkesh. I wish it was the thing we're looking for. But just think it through. Just think it through, Dwarkesh. I know you're like, yay, I get to have a complete control over humanity, yay. It's like, no, man. No, if they actually did what you wanted to do and what this computer science wants to do, which I'm sure they have something like this, it would be surprising if they didn't. But if they're gonna let regular people have a hold of it, think it through, please. Like this is the thing I get the spurgy autists when they get like enamored with the sci-fi technology, think they're gonna be the ones running it. It's like no.
We extend this to different domains.
Well, the math problems are different. Making a model of the physical world and carrying out the consequences of mathematical assumptions or operations.
Correct.
Those are very different things.
Yeah, that's a lot of computing power to get all that stuff set up to go together and run the tests. Not just one test. We're talking all the tests you need to fully explore the space. It doesn't do that. It just reads. It's just read all the reports of other people who've done similar things, and it kind of just puts a little bit here, there, combines things together for you. But is it going to run the experiments? No.
The empirical world has to be learned. You have to learn the consequences.
Right.
Whereas the math is more just computational. It's more like standard planning.
Right.
So there you can they can have a goal to find the proof, and they are in some way given that goal to find the proof.
Right. So I mean, it's interesting because you wrote this essay in 2019 titled "The Bitter Lesson," and this is the most influential essay perhaps in the history of AI. But people have used that as a justification for scaling up LLMs, because in their view, this is the one scalable way we have found to pour ungodly amounts of compute into learning about the world.
Or money. I like money. Ungodly amounts of contracts and land deals, and we're building power plants now. Everyone we're starving for power, but as soon as we get some big money coming in, and we're gonna get a lot of compute on this thing. It's gonna be compute from here to eternity. It's like, oh Jesus.
World. And so it's interesting that your perspective is that.
See, Dwarkesh, I think he's just like, he's young, right? And maybe but he does at the Army Naval College and stuff. So I know he's a little bit aware there's shenanigans in the world. So he's aware of the shenanigans in the world, but I think he's like, no, but not in this area. It's like, no, there's shenanigans to this whole thing. You don't think this is intelligence service operations? They may already have something like what we're looking for, and they just like throw it out at us, like, hey, maybe one day. But they're not going to let us actually have it. They're going to build data centers to run these things. They're not going to let us have it. They could be a mask for that. It would be perfect cover for that kind of operation, right?
The LLMs are actually not bitter lesson filled.
It's an interesting question whether large language models are a case of the bitter lesson.
Yeah,
because they are clearly a way of using massive computation, things that will scale with computation up to the limits of the internet.
Yeah,
whatever that.
But they're also a way of putting in lots of human knowledge, and so
okay.
So
okay, human. I don't know about that human knowledge. It's what humans, some humans, a very limited small set of humans have written down, and someone has chosen to put it on the internet and put it in one of these LLMs. We don't really know what the fuck goes into these things. So let's be real constant. But in his world, I guess for this guy's world in Dwarkesh, the only thing that exists are people that actually write things down and put them on the internet and have them scanned by an LLM. Is that the only stuff that matters? Everybody else can go fuck themselves? Is that what I'm hearing? Okay.
This is an interesting question. It's a sociological or industry question. Will they reach the limits of the data and be superseded by things that are...
Internet's like, what, 30 years old? Do you think the internet, the limits of the data? This species of humans have been around for what, 100 million, a million years, 2 million years? And then you're saying with the last 30 years of just the data we put on the internet is going to be the limits of human knowledge? Get the fuck out of here, guys. You need to put it back in the box a little bit. Put it back in the box. Come on now. Tamp it down. I know you just won some big prize. You think your shit don't smell. But let's calm down, okay?
That can get more data just from experience rather than from people.
Well, from the data that somebody put on the internet, or of the people that took the time to write it down. You think that's complete human knowledge? Get the fuck out of here.
In some ways, it's a classic case of the bitter lesson. With the more human knowledge we put into the large language models, the better they can do, and so it feels good.
What's better mean, sir? These large language models are pieces of shit. They lie about everything. So we're not even close. Let's keep going.
And yet, I in particular expect there to be systems that can learn from experience, which could well perform much, much better and be much more scalable.
Yeah, it's probably like what the intelligence services have. That's what they're designing our culture around, putting these things online, and half the internet's the bots of these things already running beta tests, interacting with humans online. It's like, Jesus H. Let's keep going.
Which case it will be another instance of the bitter lesson that the things that used human knowledge were eventually superseded by things that just trained from experience and computation.
I guess that doesn't seem like the crux to me, because I think those people would also agree that the overwhelming amount of compute in the future will come from learning from experience. They just think that the scaffold or the basis of that, the thing you'll start with in order to pour in the compute to do this future experiential learning or on-the-job learning, will be LLMs.
On the job. These guys are really funny. These guys are real clever. This is like end of humanity. They're just casually just a little compute. It's like this is the end of humanity they're talking about. If this has actually achieved what they want, you're done. Humanity's done. Look at that movie Elysium. We're through. It's cooked. Let's just hope they keep stumbling over those. Just a few more data centers and we'll have it. Oh man. No, not that. Let's just hope they never get it. Let's just hope they don't have it now.
And so I guess I still don't understand why this is the wrong starting point altogether, why we need a whole new architecture to begin doing experiential continual learning, and why we can't start with LLMs to do that.
Because this thing is not how things actually are. It's just it's a part of it, but it's not the thing. I know everyone's like, he says, oh, I just want my computer to do everything for me. I just want it to fix all the problems in the world. It's like, that's not what it's going to be used for, son. Seriously. Have you looked at history? I know you look at the Navy war. You think that's over? The Navy War College with that lady talking about World War II and all that shit? Do you think do you not know we're still in that? Do you think that, oh, that's over now? The Cold War ended. Oh, are you serious? And you don't think that this is going to be, if they can achieve what you're talking about, that they're not going to use it for weaponry to defeat all their enemies once and for all? And anyone that thinks they can come up and want a piece, you don't think that they're gonna come on? No, we're gonna solve all the humanity problems. We're gonna solve all the world hunger, and everyone will come to peace. Oh yeah, really? Dwarkesh, come on, man. Come on, buddy.
Well, in every case of the beer lesson, you could start with human knowledge,
right,
and then do the scalable things.
Yeah,
that's always the case. And there's never any reason why that has to be bad.
Right.
But in fact, and in practice, it has always turned out to be bad because people get locked into the human knowledge approach and they psychologically.
Right, we've already done this. We already tried. These projects have been tried and failed. We're several orders of magnitude away from achieving what humans do on a daily basis just with this stuff. Because we're 2 million years, and then we're 2 million years as humans, but we have this whole animal substrate that goes what? A billion years? A couple billion years? We don't even know. Could we go further past than that? We could be eternal. We could be trillions of years old. We have no idea. How would we know? Every time we try and discover something, so we got it, then we discovered, that's not what we thought. It's like science is constantly doing this. We have no idea. We'll never know. Well, how could you know? How would you know? We have some clues, but I think we've been here way longer. And we think that 20 years of data is going to get us near us? No.
Now I'm speculating why it is, but this is what has always happened.
Yeah.
That, their lunch gets eaten by the methods that are truly scalable.
Give me a sense of what the scalable method is.
The scalable method is you learn from experience.
Right. That means we have to have actual beings that are going out and experience, like a little baby, like actual humans, to do all, because we don't have anything like this. Nothing like this exists that we know of. Maybe the intelligence service have. Maybe DoD has something like this. I would be very surprised if they didn't have something like this already ready to go. And this is just the first little stage, roll-up stage. I don't know. This does not bode well, guys. I'm not trying to be paranoid here, but, I've seen things in the past. I've seen where they're headed with this stuff. And this whole thing, oh no, we're going to do the perfect future. And it turns out to be deadly trench warfare, killing half the men in Europe. No, we're going to have decades of peace. We're going to invent the machine gun. And that's going to make war so terrible that it'll end war. The guy that invented the machine gun, that's what he thought. So, Dwarkesh, could you please rein it in? Rein it in. You better hope to God they don't have this. And if they do, just enjoy the decline.
You try things, you see what works. No one has to tell you. First of all, you have a goal. So without a goal, there's no sense of right or wrong or better or worse. So large language models are trying to get by without having a goal or a sense of better or worse. That's just, it's exactly starting in the wrong place.
Maybe it's interesting to compare this to humans. So in both the case of learning from imitation versus experience and on the question of goals, I think there's some interesting analogies. So, kids will initially learn from imitation. You don't think so?
No, of course not.
Really?
Yeah.
I think kids just watch people. They kind of try to say.
That's not how I learned. The reason I know that this is not Dwarkesh, we were raised very differently, sir. I was raised like most of my generation with benign neglect. My parents were doing other things. They had other things they were trying to do. They had their own careers. They had their own lives. And it was part of the thing where kids could just do whatever they wanted. So if it wasn't for autodidactism, I wouldn't know shit. The school was super annoying. All I could do was wait. I wanted to go home and do my own stuff. And Dwarkesh is like, no, invitation's like, fuck no. I have to, most of the stuff I learned, I didn't learn from anybody else. I just figured it out on my own. Or from reading a book on my own. Nobody told me how to do anything. Nobody knew any of the stuff I was into at the time. Nobody knew anything about that stuff. You had to go figure it out on your own. No one was showing you. There's no YouTube videos. It was like trying shit out and breaking your knuckles, breaking a bunch of stuff, wasting a bunch of money. Stuff that does not. You find out later, oh yeah, he shouldn't have done it that way. It's like, no shit. Let's keep going.
How old are these kids?
I think the level.
What about the first 6 months?
think they're kind of imitating things. They're trying to like make their mouth sound the way they see their mother's mouth sound, and then they'll say the same words without understanding what they mean. And as you get older, the complexity of the imitation they do increases.
It's just one of the things is like very different upbringings and just very different experiences of the world, and also the solipsism that he has here is like just assuming that how he sees it is the way things are. It's like, no, dude, you need to take the other side of that. Whatever you're thinking is the way it is. Think about the other side. Think about what a criminal would be involved with doing with this stuff. Not just the nicest person on the earth. Oh boy, hunky dory, everything's cool. Like, no. Think about it for a second. Just think, Dwarkesh.
That's you're imitating maybe the skills that your people in your band are using to hunt down the deer or something, and then you go into the learning from experience RL regime. But I think there's a lot of imitation learning happening with humans.
It's surprising. Yeah, you can have such a different point of view.
Yeah.
When I see kids just trying things and like waving their hands around and moving their eyes around.
Right.
No one tells them. There's no imitation for how they move their eyes around or even the sounds they make. They may want to create the same sounds, but the actions, the thing that the infant actually does, there's no targets for that. There are no examples for that.
Just exploring the universe, exploring the world. There's goal free. The goal is, what the hell is this thing that I've been put inside of? It feels like it's all around me. Who are these things around me? These people that give me food and sometimes hit me for no reason. Like, what is going on here? Just exploring the universe. We don't have to have a goal. That's where the computer science, like super autistic, nerdy dudes like this guy's like, we gotta have a goal in chess and we gotta do math problems. Like, I wanna go paint with my fingers in the mud. Where's that in your algorithm? That was really important to do that. It teaches about viscosity, liquids, how soils are composed, what different clay, what water consistency. There's a lot of things going on, but did everybody know that at the time? No, I just want to play in the fucking mud. Borkesh. Oh, I should have been playing my violin lessons because I'm imitating the masters. Look at, I got the piano. Look, I'm going to be Beethoven. Really?
It doesn't explain everything infants do, but I think it guides the learning process. I mean, even LLM, when it's trying to predict the next token early in training, it will like make a guess. It'll be different from what like it actually sees. And in some sense, it's like very short horizon RL, where it's like making this guess of like, I think this token will be this. It's actually this other thing.
He's so enamored with this latest thing. What about the blockchain? We're enamored with that too. Oh, it's blockchain. Oh, it's a network. It's stored everywhere. It's a copies everywhere. Oh, and you have to block it in with you have to do proof of work. Blah 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 blah. Was that going to change the world? I bet you it was. It kind of did in some ways, and all of the ways it's just the same old shit we have now. Just different day, different groups of people have now powers moved around a little bit.
A kid will try to say a word, it comes out wrong.
The large language model is learning from training data. It's not learning from experience. It's learning from something that will never be available during its normal life.
Correct.
There's never any training data that says you should do this action in normal life.
Right. I think this is maybe more of a semantic distinction. Like, what do you call school? Is that not training data? You're not like going to school.
They're kind of talking past each other. He's like, how do we make this LLM? We're so close. It seems like we're so close. Yes, Dorkesh, it seems like we're close. There's certain categories of things where it's pretty good with it, but it's not perfect. You still got to know what you're doing. You still have to know everything it outputs and how to interpret it and read it if it's fit for purpose. It doesn't do that. And why hasn't it done that? Because it can't. Don't you think they would have fixed that part if they could without doing the extra stuff that this guy's talking about? He's talking about, no. Every single time it made a mistake for every single person, it should figure that stuff out and not make that mistake again. And that's what he's saying. That's true intelligence. Right. But that's not even close to anywhere near what a human does. Let's separate those two. We're talking about machines. He's like trying to convert the machine to, it's like, no, that's not humans, man. This is a tool, has a specific thing. It's good for certain shit, and other stuff it's terrible at.
Because it's like...
School is much later. Okay, I shouldn't have said never. But I don't know. I think I would even say about school. But formal schooling is the exception. You should base your theories.
It doesn't even work. It's autodidact anyway. School doesn't teach you shit. You teach yourself shit. School kind of just gets in the way. It gives you suggestions. But most of the time it's getting you in. These teachers are awful. These people are just babysitters. That's not really actually in public school. Dwarkesh probably went to private school. He probably went to private school. So he probably had a little bit nicer experience with public school teachers as a babysitting exercise. And these people just assume, oh yeah, everyone had that experience. Like, no. Now this guy kind of knows. He's had an elite experience. But Dwarkesh's like, no, everyone has that. It's like, no, dude. No. That's not how this works. Most people had none of that shit. And it seems like the leadership, these parasitic elites, think that they have to manage the people who didn't get that experience and went through the public school and are pissed off and confused and sad and lonely and sick, and they need to manage that population, and they don't want to do it. I think don't want to do it. They think this AI, this level of AI that they've publicly exposed, is going to help them manage this load of just really dumb people and that are useless and have no. There's not going to make it in this technological society. There's not. So I think they've made a decision that they're going to use this AI to manage that, and then everybody else gets to live in this other top of the K part society, and the bottom of the big fat part of the band of the K part is going to be managed to live. It's like that damn movie Elysium. This stupid goddamn movie. Oh, Matt Damon, a terrible movie, but it shows what kind of thinks the future that they want to have, that they have in mind. That what's that guy? Head of Google, Eric Schmidt says they're right on the corner of. Which if this the scientist, what this guy's saying, this self-learning stuff, if they get that, oh yeah, we're done, we're cooked. Might as well go to a farm, start subsistence for the living, because you're going to be on a UBI program, and you're going to be signed up for all kinds of programs, stuff that you're not going to want to do. So you're like, smart people are going to start another society, an alternate society off in the woods somewhere. The stuff is going to be made illegal or only for military use only, or I don't know. Once this stuff's out of the once this stuff is out of the bottle, the genie's out of the bottle with this, it's. If they have this self-reinforced learning stuff that learns 1,000 times faster than a human, and you have a network of them, and they're all trying the same things at the same time, all parallelized, humans are cooked.
This learning where I think it's just sort of programming your biology that like early on you're not that useful, and then like kind of why you exist is to understand the world and like learn how to interact with it.
Is that why we exist, sir? That's a very limited view about what humans are for. I feel sad. I feel really bad that you have this thing that's the only thing humans are good for is their utility. It's very sad, but this is elite. This is the elite. They all kind of think this way. That if you're not cognating, if you're not producing, you're a piece of shit and you deserve to die. Great.
And the seems kind of like a training phase. I agree that then there's like a sort of more gradual. There's not a sharp cutoff to like training to deployment, but there seems to be.
He's so glee and happy about this, dude. This shit's scary. Not the LLM stuff, and not actually the model, the technology itself, but what people are gonna do with it. Not the machines. That's just like retarded. It's like whatever. But what's gonna lever people who are psychopaths and sociopaths, the 3% of the population that will do anything for power, including get rid of everybody, just to make sure they can hold on to it and have an army of robots. That's the part I'm scared of. But I don't give a shit about the AI. Who cares about that? But like the people running it, those people, have you seen their track record? Holy moly.
This like initial training phase, right?
There's nothing where you have training of what you should do. There's nothing. You see things that happen. You're not told what to do. Don't be difficult. I mean, this is obvious.
I mean, you're like literally taught what to do. This is like where the word training comes from, is from humans, right?
No, he's missing. He's not understanding. Dwarkesh is just missing. He's still trying to like, no, we're so close. And this guy's like, no, man, you're like, we're talking past each other. You're talking, Dwarkesh, you're talking about this little thing domain like this that you want to like scale up and think it could be humans. And this guy's like, you understand, humans are so much more beyond anything on any of that stuff that why do we, no, man. No, no.
So I don't think learning is really about training. I think learning is about learning. It's about an active process. The child tries things and sees what happens.
Right.
Yeah. It does not.
There's no direction. The fact that we got some direction out of like math and all these little technologies or techniques or whatever is just kind of random. If somebody had to stumble across it at some point and invent it, it wouldn't just like hand it down from on high. Someone was dicking around with shit. They're just goofing off. Well, this is what the LLM stuff came out of. These network stuff is just someone trying stuff. Like that perceptron, if you know what that is, you can look it up on YouTube. This is the ninja little cell, like how it does the perceptrons with just resistors and stuff. Just people dicking around. It was totally useless. People looked at that like, that's useless. And then they tried to do it, it's like they got a little close, like, hey, well, you're getting close, but You need a lot more. It's like, well, the actual computing power needed to that even do what they were doing back then was 10 times more than they actually needed. So they were hacking it in, they're pushing it in there.
We don't think about training when we think of an infant growing up. These things are actually rather well understood. If you go to look about how psychologists think about learning, there's nothing like imitation.
Which they don't know what they're doing. They're just philosophizing. They have no idea. Computer science people are closer to cognition than psychiatrists or psychologists would ever be. Ever. Freudian, any of that stuff, get out of here. It's all philosophy and clothes, and they try to dress it up with statistics that are lies. Been proven. It's like 60% can't be replicated, so they don't know what they're talking about. He may have a better idea what's going on because he's been thinking about it, and it's like trying to replicate it with a machine. If you can replicate it with a machine that the actual process is going on, yeah, right, good. But like, okay, you might be able to do the little electrical interactions, or maybe even some of the chemicals, but all the other bonds that happen when you take a hit of DMT, how are you going to model that? That's because that's part of it. It's not that's not part of the human conditioning model, whatever, how drugs interact with our brain. You're not really there. You're just doing this pseudo thing. Okay, let's keep going.
Maybe there are some extreme cases where humans might do that or appear to do that, but there's no basic animal learning process called imitation. There are basic animal learning processes for prediction and for trial and error control. I mean, it's really interesting how sometimes the most hardest things to see are the obvious ones. It's obvious if you just look at animals and how they learn, and you look at psychology and how our theories of them, it's obvious that supervised learning is not part of the way animals learn.
Right. We don't there's not someone going over the shoulder of the animal. No, get that, not that berry. No, don't eat that berry. Go over here. No, don't jump on that branch. You jump on this. There's some there's a little bit of substrate of the hardware that has some of this stuff built in, but like humans are pretty unique. We're like one of the softest substrates, which is very malleable to a point. Not completely manual. There's 2 million years, 5 million years, 500 million years of accumulated experience that we survived up the whole chain. I know people get this, think they forget about this. We're the survivors of a long chain of fucked up shit that everybody else died, but we somehow made it through. We forget that. We just like, oh no, it's normal. It's like, no, we're the survivors of a mass death, die-offs, killing spree. Holy shit.
We don't have examples of desired behavior. What we have is examples of things that happen, one thing that followed another. And we have examples of we did something and there were consequences. But there are no examples of supervised learning. And supervised learning is not something that happens in nature. Right. And, school, even if that was the case, we should forget about it.
Dwarkesh is like, what are you talking about? All I have is supervised learning. All I know is what has been handed to me. I hope he's doing benefit of the doubt. I'm giving the benefit of the doubt. Like, is he doing devil's advocacy, or is he just like being a devil's advocate? Because he kind of seems like he really just wants this LLM shit to really be the thing that solves all human problems. It's like, well, can't we shoehorn it? Can't we just? It seems like it's like if they had it, we'd already be demonstrated. We wouldn't even be talking about it. It'd be shipping. Amazon would then acquire all companies. All companies are now Amazon. All lawyers are now Amazon. All McDonald's, all Taco Bell, everything is Amazon. And we're going like, isn't it great that we have a fully automated? All you just press a button and a Burger King, Amazon Burger King burger just comes out of a slot. Yes. Is that what you think's gonna happen?
About it, because it's just that's some special thing that happens in people. It doesn't happen broadly in nature. And squirrels don't go to school. Squirrels can learn all about the world.
Right.
It's absolutely obvious, I would say, that
and he's making fun of Dwarkesh here. It's like, it's absolutely obvious, Dwarkesh. I'm trying to be nice to you, ding dong. Like, you're in this little tiny little thing over here thinking, oh, we just scale that little stupid little toy up. And it's impressive. It does do some neat stuff, but like, you think you can just scale it up to all human experience? Are you insane? And this guy's like, Dwarkesh, now. I'd say it's obvious.
Supervised learning doesn't happen in animals.
So I interviewed this psychologist and anthropologist, Joseph Henrich, who has done work about cultural evolution and basically what distinguishes humans and how do humans pick up knowledge.
Why are you trying to distinguish humans?
Yeah. I love that he's attacking Dwarkesh. It's like, dude, what are you trying? What's going on here?
Humans are animals What we have in common is more interesting. What distinguishes us, we should be paying less attention to.
I mean, we're trying to replicate intelligence, right? So if you want to understand what is it that enables humans to go to the moon or to build semiconductors, I think the thing we want to understand is the thing that makes it
a bunch of clever people doing a bunch of clever tricks, and some of them turned out right. And trying a bunch of crazy shit that didn't make any sense to the people at the time until they did it. It was like, man, it made obvious sense. It's a bunch of people in unsupervised learning situations where they were trying shit. And dude, Dwarkesh, most of the people trying that shit, never gonna hear their names. They didn't write any papers because the experiments failed. Literally millions of these shits. There's hundreds of these guys, thousands of these guys doing thousands of millions of experiments, and they all failed except for the ones that we see. So it's this confirmation bias thing. It's like, no, it's a natural progression. Of course, blah, blah, blah. It's like, no, dude. A lot of this shit was mistakes, was like errors, was like guesses. Someone taking acid and then seeing the molecule for DNA. Where's that in your model, Dwarkesh? Where's that in your supervised learning program? These guys can, dude.
No animal can go to the moon or make semiconductors. So we want to understand.
How do you know that there's not animals on the moon? Have you been all over the moon to check if there's ever animals everywhere, Dwarkesh? Why are you real cocky about what you think is on the moon, Dwarkesh?
And what makes humans special?
So I like the way you consider that obvious, because I consider the opposite obvious. I think we need to we have to understand how we are animals, and if we understood a squirrel, I think we'd be almost all the way there.
Yeah, a squirrel is way more advanced than these stupid LLMs. Like the learning cliche model and the gradient curve of the shut up. A squirrel is about a trillion times more, like to the e to the trillion times exponent times more than a freaking LLM. Just an individual cell in that damn squirrel. You think, it's just a stupid squirrel just chasing nuts. Dwarkesh.
It's understanding human intelligence. The language part is just a small veneer on the surface. Okay, so this is great. Right. We're finding out the very different ways that we're thinking.
It's like the tiniest little side artifact of squirrelness is the chirps he makes. You think the thing that makes me up as a human being is the words that come out of my mouth that I just happen to make it on the internet? Really? People think this. Doomed. The society is doomed. They think they're gonna make an AI that simulates people. I guess with Dwarkesh around, it would be pretty easy. As long as it does the math. Oh, look, it's intelligent as hell. Look, replace all the humans. Look, it can play checkers, plays chess. Look at that. Well done, guys. Problems are all solved. Yeah, Jesus.
We're not arguing. We're trying to share our different ways of thinking.
He's douchey. He's like, you stupid ding dong. What the hell's wrong with you? Trying to elevate LLMs above a human or trying to make them equal. Come on, motherfucker.
And I think argument is useful. So,
yeah.
But I do want to complete this thought. So Joseph Henrich has this interesting theory that if you look, a lot of the skills that humans have had to master in order to be successful, and we're not talking about last 1,000 years or last 10,000 years, but hundreds of thousands of years. The world is really complicated, and it's not possible to reason through how to, let's say, hunt a seal if you're living in the Arctic. And
who says it's not? Wait. You're saying that sticking something through the ice that's fish on it, and then using that as bait to bring up a seal and stabbing it with another stick is gonna be hard to figure out? I mean, maybe sharpening the stick, digging the hole, going out to the sea, figuring out how to do that, have clothes on. You think that people can't step through this, Dwarkesh? Have you ever been hunting? I don't think he's ever been hunting.
So there's this many step long process of how to make the bait and how to find the seal and then how to process the food in a way that makes sure you won't get poisoned.
Some people are gonna get poisoned. That's how we know. Dwarkesh, do you think we're gonna get around the poisoning without someone dying from the poisoning or getting real sick from the poisoning? Dwarkesh!
And it's not possible to reason through all of that.
Yeah, it kind of is. Huh? Are you listening to words coming out of your mouth, Dwarkesh? Sometimes, man, I don't know, man. These guys are a little too book smart for their own good.
And so over time, yes, there's this larger process of whatever analogy you want to use, maybe are something else, where culture as a whole has figured out how to find and kill and eat seals. But then
culture as a whole, no, my dad showed me. And his dad showed him. And his uncle died when he ate this thing that he wasn't supposed to eat. So we don't eat that no more. But it took us, his kid ate some too, and it took us a while to figure out what was going on. Aren't you glad that we figured that out and told you? But someone had to die. Someone had to figure it out. Someone had to go over there and dig a hole with the seals and put some things in the seals. Someone had to notice that the seal liked fish. Someone had to notice how you could make a little hook out of a thing and put the fish on there. It's so weird, man. Okay, keep going.
And what is happening when through generations this knowledge is transmitted is, in his view, that like you just have to imitate your elders in order to.
You don't have to imitate them. They can just tell you. I mean, he can show you, or just watch them. I mean, there's certain skills, yeah, you may need to watch them, but there's certain skills you may have to just invent on your own and come up with stuff. Or it might get lost, or it might get misplaced, or it's just not important anymore. You have to relearn it some other way. I don't know what his point is.
Learn that skill, because you can't think your way through how to hunt and kill and process a seal. You have to just watch other people, maybe make tweaks and adjustments, and that's how knowledge accumulates. But the initial step of the cultural gain has to be imitation. But maybe you think about it a different way?
No, I think about it the same way.
Okay.
But still, it's a small thing on top of basic trial and error learning, prediction learning.
Yeah.
And it's what distinguishes us, perhaps, from many animals. But we're an animal first.
Yeah.
And we were an animal before we had language and
way before that.
all those other things.
I do think you make a very interesting point that continual learning is a capability that most mammals have. I guess all mammals have. So it's quite interesting that we have something that all mammals have, but our AI systems don't have, right? Whereas maybe like the ability to understand math and solve difficult math problems depends on how you define math. But like this is a capability our AIs have, but that almost no animal has. And so it's quite interesting what ends up being difficult and what ends up being easy.
Morvik's paradox.
That's right. For the era of experience,
Morvik's paradox.
Engineer data, the world with a ton of experience have covered the kinds of things, cool demos, environments,
Lay out a little bit about what it is.
Back to Richard. This alternative paradigm that you're imagining.
The experiential paradigm.
Yes.
Let's lay out a little bit about what it is. It says that experience, action, sensation, action, reward, and this happens on and on and on, next to our life. It says that this is the foundation and the focus of intelligence. Intelligence is about taking that stream and...
Well, it's one aspect of it. It's not the thing. That's the one thing that's one of the things I like. I always like, you do think you got intelligence all figured out? You're gonna have to explain a lot more than just how humans work if you think you got that. But let's keep going.
Altering the actions to increase the rewards in the stream.
Right.
So learning then is from the stream, and learning is about the stream. So it's that second part is particularly telling. You know, what you learn, your knowledge is about the stream. Your knowledge is about if you do some action, what will happen, or it's about which events will follow other events. It's about the stream. It's the content of the knowledge is statements about the stream. And so because it's a statement about the stream, you can test it by comparing it to the stream, and you can learn it continually.
So when you're imagining this future continual learning agent,
they're not future, of course. They exist all the time. This is what reinforcement learning paradigm is: learning from experience.
Yeah, I guess maybe what I meant to say is human level general continual learning agent. What is the reward function? Is it just predicting the world? Is it then having a specific effect on it? What would the general reward function be?
The reward function is arbitrary, and so if you're playing chess, it's to win the game of chess. If you were to, if you're a squirrel, maybe the reward has to do with getting nuts.
Right.
In general, for an animal, you would say the reward is to avoid pain and to acquire pleasure.
Right.
And there's also would be a component having to do with, I think should be a component having to do with your increasing understanding of your environment. That would be sort of an intrinsic motivation.
I see. I guess this AI would be deployed to, like, lots of people would want it to be doing lots of different kinds of things.
Right.
So it's performing the task people want, but at the same time, it's learning about the world from doing that task. And do you imagine? Okay, so we get rid of this paradigm where there's training periods and then there's deployment periods. But then do we also get rid of this paradigm when there's the model and then instances of the model or copies of the model that are, doing certain things? How do you think about the fact that we'd want this thing to be doing different things? We'd want to aggregate the knowledge that it's gaining from doing those different things.
I don't like the word model when used the way you just did. I think a better word would be the network. So I think you mean the network. Maybe there's many networks. So anyway, things would be learned, and then you'd have copies and many instances, and sure, you'd want to share knowledge across the
just like humans, okay,
instances. And there would be lots of possibilities for doing that. Like there is not today. You can't have one child grow up and learn about the world, and then every new child.
But even this transmission mechanism of language, human language, and noun, verbs, and all these grammatical constructs, and the variability of the English language, and then having to drop down to a mathematical language, even then, that you're not really going to be able to describe all the things we're talking about, because there's only that's its own like universal domain that sometimes bleeds through to the reality domain, but not always, has some little quirkiness, strange things, but just one way of thinking about things. And it's not the only way of thinking about things. There's all kinds of ways of thinking about things that aren't on the internet that you'll never see, that people can't even verbalize. You know what am I talking about? Does this make any sense? Like falling in love. How would you tell a machine how that worked? What would it even mean? Well, they got a billion poems about it, but to experience that actually as a human being, how would you put that into your model there, Dorkesh? How are you going to put your learning system towards that? Where's your goal oriented thing when it's just the feeling of just seeing somebody else and feeling that wonderfulness? There's no goal. Where's that? And then it's fleeting. Where's that? That you can't just do a computation and make it appear. That's a big part of being a human being. Nobody talks about that. Where's that in your fucking model?
To repeat that process. Whereas with AIs, with a digital intelligence, you could hope to do it once and then copy it into the next one as a starting place. Right. So this would be a huge savings, and I think actually it would be much more important than trying to learn from people.
Yeah, they call that DNA. They calls it the people that survived long enough to talk about it and pass it along, and then maybe tell you about it or not, or just your DNA's there, so you have the capability of figuring it out. Maybe not. Maybe you eat the bad meat. Maybe you're the one that's the story we talk about for the next 25 years. Oh yeah, don't eat the bad meat.
Mm-hmm. I agree that.
Remember what happened to Chris with the bad meat?
The kind of thing you're talking about is necessary regardless of whether you start from LLMs or not, right? If you want human or animal level intelligence, you're going to need this capability. Suppose a human is trying to make a startup, right? And this is a thing which has a reward.
The fucking startups.
On the order of 10 years. Once in 10 years, you might have an exit where you get paid out $1 billion. But humans have this ability to make intermediate auxiliary rewards, or have some way of, even when they have extremely special rewards, they can still make intermediate steps, having an understanding of like what the next thing you're doing leads to this grander goal we have. And so how do you imagine such a process might play out with AIs?
So this is something we know very well, and it's the basis of it is temporal difference learning, where the same thing happens in a less grandiose scale, like when you learn to play chess. You have the long-term goal is winning the game, and yet you want to be able to learn from shorter-term things, like taking your opponent's pieces. And so you do that by having a value function which predicts the long-term outcome.
Right.
And then if you take the guy's pieces, well, your prediction about the long-term outcome is changed. It goes up. You think you're going to win, and then that increase in your belief immediately, quote, reinforces the move that led to taking the piece.
Mm-hmm.
Okay, so we have this long-term 10-year goal of making a startup and making a lot of money. And so when we make progress, we say, oh, I'm more likely to achieve the long-term goal, and that rewards the steps along the way.
Right. And then you also want some ability for information that you're learning. I mean, one of the things that makes humans quite different from these LLMs is that if you're onboarding on a job, you're picking up so much context and information, and that's what makes you useful at the job, right? You're everything from how
tacit knowledge, yes,
your client preferences to how the company works, everything. And is the bandwidth of information that you get from a procedure like TD learning high enough to have this like huge pipe of like context and tacit knowledge that you need to be picking up in the way humans do when they're just like deployed?
I think the crux of this, and I'm not sure, but the big world hypothesis seems very relevant, and the reason why humans become useful on their job is because they are encountering a particular part of the world.
That's right.
And it can't have been anticipated, and can't all have been put in advance. The world is so huge that you can't. The dream, as I see it, the dream of large language models is you can teach the agent everything, and it will know everything, and it won't have to learn anything online during its life. Okay, and your examples are all, well, really you have to, because there's a lot you can teach it, but there's all the little idiosyncrasies of the particular life they're leading, and the particular people they're working with, and what they like as opposed to what average people like. Right. And so that's just saying the world is really big, and so you're going to have to learn it along the way.
Yeah. So it seems to me you need two things. One is some way of converting this long run goal reward into smaller auxiliary, or these like predictive rewards of the future reward, or the future reward that leads to the final reward. Then you need some other way. Initially, it seems to me you need some way of then, okay, I need to hold on to all this context that I'm gaining as I'm working in the world, right? I'm like learning about my clients, my company, all this information, and
I would say you're just doing regular learning.
Yeah.
Maybe using context, because in large language models, all that information has to go into the context window.
Right.
But in a continual learning setup, it just goes into the weights.
Maybe context is the wrong word to use, because I mean a more general thing.
You learn a policy that's specific to the environment that you're finding yourself in.
Yeah. So the question I'm trying to ask is, you need some way of getting like how many bits per second are you picking up? Like, is a human picking up when they're, out in the world, right? If you're just like interacting over Slack with your clients and everything.
What's a bit? I think that's a good place to stop it for right now. I'm going to continue on the rest of this thing, but I don't want to go out for over an hour. But like, okay, Dwight, what's a bit? How would you know how many bits of information is coming in? It's just through your eyes, it's through your ears, through your skin, temperature, tension, skin. No, only smells. I got the smell off. Can I get the smell off real quick? Can I eliminate that one for my model? All right. Give me a hate like, give me a hate subscribe, and I'll talk to you soon.